Okay, Unit 3. Here we go. Continuing with derivatives. Building on it. As you said, it's what? Differentiation part 2. So we are going to start with chain rule. Okay? The idea of chain rule is how do we take the derivative when essentially it's a composition of functions, when there's a function inside of a function. Okay, we know how to take the derivative of individual functions, but like for instance, we have to use the product rule when there's two functions multiplied together. Or if there's two functions divided, we have to use the quotient rule. Well, here we're going to have the chain rule that allows us to take the derivative when you have a function inside of a function. Okay, so chain rule is used to differentiate composition functions, such as y equals the square root of x cubed plus 2, or y equals sine of x squared. Remember, you create a composition by plugging one function into the other. The composition of f and g is f composed with g, or f of g of x. We can find the derivative of each separate function by using the rules we've learned so far. But we need the chain rule to find the derivative of two functions plugged into one another. So, the chain rule. If f and g are differentiable, then the composite function, fog, f composed with g of x, or f of g of x, is differentiable, and notice what it says there, f prime of g of x times g prime of x. So looking at that, it's the derivative of the outside, then times the derivative of the inside. So the derivative of the outside, you keep the inside the same. And then you multiply by the derivative of that inside that you just kept the same. Okay? Leibniz notation will allow us to use u substitution. So if y is f of u and u is g of x, notice that y is a function of u is a function of x. So his notation says that dy dx is equal to dy du times du dx. This looks more complicated than it really is. Basically, chain rule says multiply the derivative of the inside function by the derivative of the outside function. Okay, you just don't do them at the same time. So, let's look at example 1. Because I can explain this as much as I want, but really, we just need to do it. Okay, so example 1. Find the derivative of f of x equals 5x plus 3 squared with and without the chain rule. So, if I ask you to find the derivative of 5x plus 3 quantity squared, before learning anything new today. Okay, we would FOIL it and then find the derivative. So let's do that. So if we FOIL this, f of x will become
38.
So then if we want the derivative, okay. Now, and we're using this so you can understand when I do the chain rule here in a moment that it is truly indeed the same thing. Okay? And I don't know about this one, which one would be easier, but traditionally the chain rule is going to be an easier method. Sometimes it's our only method. This one we have an option. Now, the idea with the chain rule. So I'm going to write down the original problem. F of x is 5x plus 3 quantity squared. When we do the derivative via chain rule, okay, first of all, the reason this has to be a chain rule problem, if you're not going to FOIL it out, is that we have an outside function and we have an inside function. So what is our outside function?
Square.
The outside function is that we have something squared. How do you do the derivative of something squared?
2x.
Okay, so to apply it to here, you're going to take the 2, move it out front, the parentheses, and then your power, you subtract 1, it becomes 1, right? In this problem, we don't do anything with those with what's in the parentheses. So 5x plus 3 is going to stay 5x plus 3 on the first go round. So we just did the derivative of the outside function, which was something squared. Now, after you do the derivative of the outside, keep the inside the same. Now you're going to multiply by what's the derivative of the inside. So what's the derivative of 5x plus 3? 5? Okay. Technically, you're done there. I would say to clean it up some. Not that you necessarily have to, depending on what you're doing. But this 2, I would say this 2 and this 5 out front can become 10. And then you have 10 times 5x plus 3. And hey, guess what? 10 times 5x plus 3 is 50x plus 30. So there's my proof. Did it work? It did. Okay. Officially, this is a good answer. This is a good answer. That's an equivalent answer. Technically, could any of those answers work? They could. Okay.
So the way we got the 5 on the outside is the derivative of the 5 on the inside.
The derivative of 5x on the inside. Yep. Okay, we got the basics. I mean, obviously, the more we practice, the more it will start to sink in. So, example 2. Find f prime of x given that f of x is 4 minus x squared quantity cubed. Now, unless you want to cube this one out, like FOIL method, this is why we start talking about chain rule. Okay? So, start with derivative of the outside function. What is my outside function? Yeah. You need a... The outside function is, what do we do when it's something cubed, right? So what are we going to do here? 3. And? Wait, power of 2? Because the derivative of something raised to the third power. Multiply 3 out front and subtract 1 from the power. So 3 minus 1 becomes 2.
I was wondering, I thought it was like a derivative symbol up there on the last one.
No, that's a 1.
I had no clue what that was, but I was just going with it because it didn't affect anything. So
Okay, it's a 1. Okay. So that's derivative of the outside. Notice we didn't touch the inside. Times.
It would be negative 2x.
Negative 2x. I agree. Okay. I just put parentheses around it because it is a negative. I would clean it up a little bit. You know, I don't know that you have to. Traditionally, you usually do. And what's the little bit of cleanup I'm going to suggest?
Negative 6x minus x squared 1b squared.
So we can keep the square on the outside?
I would, yeah. Yeah. Especially since we didn't FOIL it out to begin with. You don't really need to FOIL in the end. Okay?
Oh, that's where DocDiff comes from. Sorry. I watched a couple videos on it.
Oh. I've never... It makes sense, especially since she has it bolded. I've never heard DocDiff, but I get it. Okay, I guess the one other thing I never... Not that I really have to, but... outside was x cubed. And I was going to write down. Inside was 4 minus x squared. Okay. Moving on. Okay, so general idea here, okay? If g of x is differentiable, and this is really just expanding on what this is just another way to talk about chain rule. But if you're trying to do the derivative of g of x raised to the n power, Notice is what we were just doing. Bring the n out front, keep g of x, subtract 1 to a power, so n minus 1, and then times the derivative of g of x, so g prime of x. The other one we're going to experience on this page is the derivative of doing e to some function, so e to the g of x. Remembering, what is the derivative of e to some power, is what you'll often hear me ask. Well, derivative of e to the x is e to the x, right? So derivative of e to some power is e to some power multiplied by the derivative of some power. Okay? Okay. We've got a whole ton of practice. So, as we look at A, what are your thoughts, your initial thoughts on A? F of x is the square root of x squared minus 1 to the third power of 3. What should I do to get me started?
You don't have to use that top part, do you? You can just use that chain rule.
It's the same. Yeah. This is just a different way to specifically relate to these, but it's a chain rule.
I would say 2 over 3. You say negative. That would be 3 over 2, wouldn't it?
Yeah.
That's the denominators.
Yeah.
Okay, so you guys are in the process of rewriting this before we get started?
Yeah.
So it's x squared minus 1 to the 3/2 power is another way to write f of x, yes?
Yeah.
And you need to do that, at least mentally do that, before you actually take your derivative. Okay, how's your derivative going?
So it's going to be 3 halves, and then parentheses x squared minus 1 on the 1/2 square root. Just do 1/2.
Do 1/2. Worry about the square root later if you put it back in.
Times 2x.
Did you get it?
Yeah.
Okay. Now, again, I would definitely encourage a little bit of cleanup. You're not going to see a multiple choice answer like this. What cleanup do you see?
3x.
So yeah, it just becomes 3x.
Because the 2's can cancel there? The half and the 2?
You can make it square root of x squared minus 1 if you wanted to.
Right. So you could write it as 3x times x squared minus 1 to the 1/2. Or, and what I did in my answer key is I went that extra step and I said 3x times the square root of x squared minus 1. It's not perfect, but my general rule of thumb, and I can't say that I always stick by this, but if they had it in square root form to begin with, I try and go with the thought of, okay, I'll put it back in square root form. I'm not saying I always do, but that's what I, try to aim for.
The only fear is making sure you don't get that 3x in the square root. In my opinion.
Yeah, you definitely can't have the 3x in the square root, which is why we put it out front. Okay, B? What are you doing first?
Fixing it.
And what does he mean fixing it?
Negative.
It would become like. Because it's still negative second power. What is that?
So are you saying, did you already write this out?
I was working on it.
Yeah.
Okay, that's what I was trying to figure.
It's negative 7.
So the negative 7 is on top. So that I put that out front generally. And then 2x minus 3 becomes the negative second power is your best option here.
So then
So what are we doing?
14
Okay.
times 2x minus 3 quantity in the negative third times 2.
Uh-huh. Derivative of the outside times derivative of the inside. Cleanup options.
Yeah, I would put it over 20 over 2x minus 3 quantity of 3.
Okay, so yes, I do agree. Most of the time you're going to want to go back to that fraction form. So often they say don't leave a negative exponent. And so, again, calculus is a different beast. There are times when you are forced to leave negative exponents, but you're going to see your answer more as this, where you get rid of that negative exponent. Okay. You guys are making this too easy on me. I'm sure we'll hit the difficult ones, but okay, keep moving. C. Y equals 5 minus 4x squared raised to the 2/3.
2/3 5 minus 4x squared quantity negative 1/3 times
Eight. Negative.
Yeah.
Okay, I like it. I like it so far.
Y prime equals 8 times
42 over
16 over 3. Negative 16 over 3.
Yeah, if we think 8 over 1 times 2 over 3.
Yeah.
Negative 16/3 x times 5 minus 4x squared raised to the negative 1/3. Or at least, I don't know if you guys put this step in or not, but that's what I did.
So then it would be 5 prime would equal negative 16x over 3 parentheses 5 minus 4x squared quantity 1/3 or cube times
Or the cube root of 5 minus 4x squared.
8. I gotta write that.
Okay. Again, not necessarily, well, and actually as I look at the original problem was with a 2/3. So would it kind of make sense to leave a 1/3? It would. It could also go to a cube root. Okay. Okay. D. Y equals e to the 3x squared. So y prime.
Y prime equals, so it would be 3e.
No.
Sure. That's what the top looks like, the top part you showed us.
Well, okay, so the top part talks about g prime of x. So the derivative of g of x times e to the g of x.
So it'd
How?
be 6x e.
Continue.
6x e and then 3x squared to 3x squared.
Yeah. So how I think through this one, because I don't necessarily use what they have there, is I see e to some power. What's a derivative of e to some power? And the derivative of e to the x is e to the x, so derivative of e to some power is e to that power. And then we have to say times the derivative of that power. And the derivative of 3x squared is 6x. That's how my brain talks through it. Now, is that how I'm going to write my final answer? Probably not. I'm probably going to flip them and say that this is 6x e to the 3x squared. Okay? So now how they wrote it is probably more how we traditionally write it. Again, varies from problem to problem, but okay, good. Okay, e. Y equals negative 2 over the cube root of 6x plus 3.
So it would be y, or we'll just let's fix y. Negative 2, and then parentheses 6x plus 3 quantity negative 2/3.
I have.
Why negative 2/3?
Yeah, I don't know.
Okay.
Okay.
Fair enough.
And probably because I was initially thinking square root, and then I changed to cube root, and
Yeah.
Midstream, and you combined them. Okay.
Prime equal. So it'd just be 2/3. Oh my gosh, work, you stupid pen. 2/3. 6x plus 3 quantity. Negative 4/3. 6.
Okay. I would definitely clean up.
Prime equals. I'm just going to go 4 over. Right?
Yeah.
Yeah, you can do that.
4 over 6x plus 3 quantity 4, or I can do the 4th root of a cube, I guess.
So yeah, 2/3 times 6 ended up being 12/3 or 4. And then I have that 6x plus 3 to the negative 4/3. So it can go down the denominator as a 4/3 power, or it could go down there as the cube root of 6x plus 3 to the power of 4. And like I'm always going to say, understand both. Both are equally good. You just have to be able to understand both. Okay. Before we get started on F, I want to do a rewrite. This is cosine cubed of e to the 5 theta. Cosine cubed is another way of saying cosine of e to the 5 theta raised to the 3rd power. And I'm doing that because I need you guys to understand what the most outside function is here. There's because there's two different ways. Cosine cubed theta is equal to cosine theta quantity cubed.
Yeah, I understand that, but why can't you just make the e to the 5 theta cubed magically?
I did make the e to the 5 theta cubed. This is outside a bracket. This is making the whole cosine.
So the e to the 5 theta would be like x in this instance.
It's your variable, yes.
That's what I would understand.
The e to the 5 theta is the inside piece of the cosine function. So instead of saying cosine of x or cosine of theta, it's cosine of e to the 5 theta. Let's just say this one's going to be fun. I don't know if you guys are realizing the fun we're getting ready to have, but... Okay. What is my outside function?
Cubed.
Cubed. So how do we do the derivative of something cubed?
3 out front.
Mm-hmm.
3 cosine e to the 5 theta.
Okay.
Time.
Okay, so the outside power was cubed. So 3 times the inside, cosine of e to the 5 theta, raised to the power of 2.
And then the times.
Times. What's my next function?
Well, it's the derivative of 5 prime times, or not 5, the derivative of e, the derivative of 5 theta, e 5 theta.
Not yet. before we get to the e to the 5 theta,
Negative sign.
there's a cosine function. I told you, we're getting ready to have fun on this one, okay? So the outsidemost function was the cube power of 3. The next outsidemost function is cosine of something. How do we do the derivative of cosine of something? The derivative of cosine of something is negative sine of something. Why do I keep saying something? Because we've got to put that something back in there. Now, am I done yet?
Wish.
Okay, fair answer. The chain rule can be used repetitively. It's not just, in this case, there's multiple inside functions. So we did cubed. Then we did the derivative of cosine of something is negative sine of something. Now, what's the derivative of something? So what's the derivative of e to the 5 theta?
Root of 5 theta, e 5 theta.
Well, no. What's the derivative of e to x?
E 5 theta.
Derivative of e to the x is e to the x. So derivative of e to the 5 theta is e to the 5 theta, yes? Or what's the derivative of e to some power? It's e to some power. Times, we got to do the chain rule one more time. What have I not taken the derivative of yet? 5 theta. What's the derivative of 5 theta?
Nothing.
Theta is a variable, so what would be the derivative of 5x? 5. So what's the derivative of 5 theta? 5.
5 theta isn't a constant, so it's 0, so therefore the whole thing's 0.
Theta is not a constant.
That doesn't count.
Oh, okay. You're just wishful thinking, right?
Yeah.
Okay. Now,
I feel like that's something they would do.
in terms of cleanup, there's really not a ton of cleanup that can be done, other than we can put our constants together. And when I talk about putting our constants together,
So maybe like
15 cosine.
and I would go ahead and also take
negative.
the negative, so you don't have a negative in the middle of everything. So I'm going to say negative 15 out front. I am going to rearrange a little bit. I don't know if you'd have to. I'm going to pull that e to the 5 theta out front. So negative 15 times e to the 5 theta. And then you could grab the sine or the cosine next. I'm going to say sine of e to the 5 theta. And then what about this cosine? It's cosine what? Cosine squared. So you could actually put that squared back in and say cosine squared of e to the 5 theta. Okay. Now officially, does it have to be that order? Absolutely not. You just need those pieces.
Look how much more cleaned up it is.
Not a whole lot, huh? Is that where you're going with that comment?
Yeah.
That's pretty good. Yes,
It did. It gets messy. So there's your first example where chain rule. You take the derivative until you can no longer take the derivative. Okay? The chain rule keeps circling around. Questions on that one?
Is it going to be in the test?
Huh?
Is it going to be in the test?
Possibly. We're in day 1 of the next unit. You're asking about the test?
Yeah.
Okay. G.
Could be doing.
F of x is natural log of x squared plus x plus 1 quantity squared. I would do one rewrite before you get started here.
2 natural log.
A power of 2 in a log setting can be rewritten as a coefficient of 2, according to our log rules. Does that sound familiar?
Vaguely.
No.
So I would rewrite this as 2 times the natural log of x squared plus x plus 1. Okay. So, what is our function here?
Doesn't it just become 2 natural log because it's to the 0th power, or would the whole thing become 1? Because if that's to the first power up there.
This isn't a power rule though. Natural log has its own derivative rule. The derivative of natural log of x is 1 over x. Just like the derivative of e to the x is e to the x. Those were special rules that we're supposed to know. Okay? Okay, so that 2 is a constant out front, so it can just tag along. The big thing we have to look at is we're looking at natural log here. What's the derivative of natural log of something?
1 over something?
Yeah, if the derivative of natural log of x is 1 over x, the derivative of natural log of something is 1 over something. Now, this constant of 2, you can just leave the constant of 2 out front. And then we said 1 over something, so 1 over x squared plus x plus 1 times. So we just did the derivative of natural log of something. Now, what's the derivative of that something? So I'm saying, what's the derivative of x squared plus x plus 1?
It would be 2x plus 1.
So, in order to write this, one option, I mean, technically, this 2 could stay out front, or, I don't know if log derivatives are coming back to you at all, but when we did the derivative of natural log of something like this, we had 1 over x, we would put that 2 on top. So we could put that 2 on top. We could also put that 2x plus 1 on top.
4x plus 2, x squared plus x plus 1.
Yes. What I was starting to write it as before you said that was 2 times 2x plus 1 over x squared plus x plus 1. However, I also have an or written in here that says 4x plus 2 over x squared plus x plus 1. Okay? Okay. You like this one, Eli?
Yeah.
It's actually going to work out to be really nice once we do. And always try and do a little bit of cleanup before you get started if there's cleanup to be done. Okay? Now, what I'm going to suggest here is there's definite cleanup to be done if you can recognize it. I'm going to rewrite this as x squared times e to the, I'm going to take that -4 to the power here. So it's natural log of x to the -4. Do you remember anything about e to a natural log power?
1 over 1.
No?
No.
Well, it depends. So here we have e, and remember natural log is also base e, yes?
Yeah.
And when this base and this base are the same, basically they cancel and you're equal to whatever you have inside the log, which is x to the negative fourth. So this could actually be rewritten as x squared times x to the negative fourth. Okay, is that making sense a little bit? The idea is that e to the natural log of x to the negative fourth, because these are both the same, basically all of this drops out and you just have x to the negative fourth. Okay, that works when it's a log in the power. Now, what is x squared times x to the negative fourth?
What?
X to the negative second.
So, what I'm proposing is f of x actually cleans up to be x to the negative second. Very nice, isn't it? Now, keep in mind, have we done the derivative yet? We have not. What's the derivative of x to the negative second?
Please excuse this interruption. If you are a senior and you need more discount cards to sell, please come to the guidance office at this time. Again, if you're a senior and you turned in your money and are waiting for more discount cards, please come to the guidance office at this time. Thank you.
Yeah, I turned in the money earlier because I gave my last one to Corn, so I'm technically out.
I figured as much, so.
Because I actually remember texting this morning because I had reminders.
Wasn't there someone that sold like 90?
Just
Okay, do you want to head down there now, or do we do one more example?
you can get one.
Although the next one's kind of big, I'm realizing. But, well, maybe it's not as big as it looks. Maybe it's just a cleanup. Okay, one more real quick.
Well, isn't that just,
Now keep in mind,
isn't that just, can that become just
4x.
are you thinking about Pythagorean identity?
Yeah.
That's sine squared plus cosine squared.
Can we multiply everything by -1?
No.
Wait,
True.
Then,
Yeah.
Then you still have the wrong
Then
sign.
you get negative 4x.
Okay, no. What I'm looking at is squared minus squared here.
Yeah.
Okay, so with that in mind,
I mean, I guess I hope she just doesn't run out of the rooms this fast. I hope she has plenty to go around.
I hope so too. She had ordered, I think, what, 200 more?
Let's hope Jocelyn is good.
Johnson better not go.
She's cut off right now until everyone else gets a chance. Okay, what are we doing? If it's cosine of 4x, I keep pulling that 2 out so you'll see it better. Cosine of 4x quantity squared, what's that derivative?
I did not process anything you just said.
Okay.
2 negative or -2 sine 4x.
Nope.
What did you ask?
Trying to do derivative of cosine of 4x raised to the second power. What's the outside?
Negative 8 sine of x.
Chain rule. We all of a sudden just went kaput. What's the outside power? Or the outside function?
So
How do you do the derivative of something raised to the second?
do them 2 cosine 4x times
So raised to the first, technically, yes.
times negative 4
Sine x.
Okay, so I'm going to do it in pieces, but yes. What's the derivative of cosine of 4x? Derivative of cosine of something is negative sine of something
That's what I just said.
times what's the derivative, and we still have a something here, don't we? So what's the derivative of 4x? That's a 4. Okay, minus. Same thing on the other one.
That whole thing is minus.
It was a minus in the original problem.
But can you put parentheses on that thing or no? whole thing minus.
No, it's just the whole next term is going to. I will have parentheses here in a moment. Okay, so sine to the 4x raised to the second power. Something raised to the second power, we do what?
2
2 times sine of 4x, technically raised to the first power, so that's the power of 2. Now we're doing the derivative of sine of something, which is,
isn't it negative, so
Negative cosine, or
it's minus sine 4x squared.
well, there's a minus sign out here.
yeah.
We don't need,
Since when does the whole thing now subtract?
it's one big term multiplying together. It's one big term. I mean, if you want, you can put this whole thing in parentheses, but we don't keep saying minus. Is that what you're saying?
Well, I have that as addition. I have everything else subtracted in addition.
Yeah, but if it's
To me,
so, if you're subtracting sine, it's negative sine, and isn't the derivative of negative sine negative cosine?
but okay, we're gonna have to finish this one tomorrow. I'm not.
It's negative sine.
There's no negative sign. This is a subtraction sign. This is in between the two terms.
Makes it minus sine.
Well, we're just subtracting. My view is we're subtracting whatever we take. We're subtracting the derivative of sine to the 4x raised to the second. So we're subtracting all of that business there. As I said, we'll have to get this cleared up tomorrow.